Genesis 1:14 and 15 and 16. And God said, "Let there be lights in the firmament of the heaven, to divide the day from the night, and let them be for signs, and for seasons, and for days and years. And let them be for lights in the firmament of heaven, to give light upon the earth." And it was so. And God made two great lights, the greater light to rule the day, and the lesser light to rule the night. He made the stars also. Bible smack! Alright, so today we're going to be talking about the solar system. Now, the biblical view, as you see on day 4, is that the solar system is mentioned as the sun and the moon and the stars. In other words, it was not isolated. And much as we learned in the last class about the physicist N.Y.C, science connects all the universe physically together, and everything affects something else in the material world. And so Mach agrees with the ancient biblical cosmology. Now, as we've been building up to this, I think this is the part where people do have a message that gives them cognitive dissonance. In other words, they've been trained all their lives to not understand things this way. But what we have covered has answered the big, tough issues, and it has constructed a geocentric universe. Now, New Year's cosmology is not just about geocentrism, but that is definitely a powerful point to it. And so today we're going to go ahead and we're going to look at the solar system. I think one of the problems that we have is that we have a limited understanding of the solar system. We only think in two concepts. Earth is so small. Sun is so big. Obviously, Earth go round Sun. What about the rest of the universe? And also, what about the nature of these things? Where did the solar system come from? Like I put a little emphasis. Come from. All right. So, now as we look at the origin. Now, historically, that is the origin of the solar system. And the origin of stars comes later on, even though that is the background. And this is why we have a limited vision of this stuff. You see, the sun is supposed to be treated like other stars. But have you ever even asked the question, is the sun necessarily operating the exact same as every other star? Are all the galaxies the same? Are all the stars and all the planets the same? We're making assumptions here. Not that we necessarily have to throw it down, but we have to put it in its proper place, proper order and understanding. And so, as Neil deGrasse Tyson would think, we're stardust. What he's actually doing, and what we've come to, is we assume that the planets and the whole solar system is all wrapped around that sun. We've went down that road of heliocentrism for centuries, and we've put it into our subconscious so that we never had to criticize it. But think about it this way. Where did the stars come from? Now, in the Big Bang video, I explained how they don't make any sense. They say, okay, stars are born out of gases. And then they'll tell me, we've got proof. What is their proof? Well, they'll take a picture of a space cloud or a giant nebula. And they get bigger and badder telescopes. And so now they got their big Hubble telescope. And they're zooming in and zooming in and zooming into this big cloud. They find a light that they didn't find before. And they say, oh, a star is born. Well, I'm sorry, but this ain't Hollywood. You see, what it is that if they looked out into the night sky and there was nothing but pitch black, and then they zoom in and zoom in and zoom in, they would say, oh, we found new galaxies and new stars. But they don't tell you, oh, new galaxies and new stars are born. Why? Because they have an agenda, and that agenda is guiding that. But actually, as the Harvard physicist Abraham Loeb once said, we do not understand star formation at a fundamental level. If we don't understand star formation at a fundamental level, and we say that the sun formed us, there's a problem. All of the planets cannot be explained if star formation cannot be explained. And so we're designing this whole setup for this naturalist system. But the problem is we got an assumption built on assumption built on assumption. You have a Big Bang that came from nothing. You say, who made the Big Bang? Nothing made the Big Bang. Big Bang made the universe. So nothing made the universe. So what is the universe made of? Nothing. Oops. See, we actually have to have a real explanation for real things. And so, what is the explanation of this star making the planets? Well, they assume that the star attracted all these gases and all these dust, and they all vortexed around the sun. And eventually these dust, not only does the dust pile up to make fusion and make a star, but the dust would also pile up and make gravel and particles and eventually planetoids. So planetoids are pretty much the exact same as asteroids. And then these asteroids would bang together and then form a perfectly round ball. But is that the evidence? Is that the reality? The fact is when we're talking about this whole vacuum of space, everything's moving extremely fast. I believe the Earth is supposed to be spinning at 1,500 kilometers per hour. Well, if it's moving that fast or much faster, I know that we talk about 33 miles a second, but basically, if we start moving at that level, then all the things that are moving around the sun are moving at that level. So, what's going to happen to the dust? Is the dust going to just come and stick together and everything is going to be great because the dust has so much gravity? No, the dust doesn't have hardly any gravity. And how is the gravity going to get things together? But even worse than that, let's say we get a couple clumps together. Great, you got dust clumps. And let's say, I was able to make a rock. What is the rock going to do with another rock? Is it going to build? If it's going 1,500 kilometers a second? I don't know, 1,500 kilometers an hour. If they're going at these rates, okay? If they're going 10 miles an hour and they smack into each other, what's going to happen? Bang! They don't make planets. They don't build up to that. The amount of asteroids and comets is not even that much in our solar system. You could pretty much fit it into the planet Earth. All of them. And probably less than that, but I have to go back and check my records. But basically, when you talk about this stuff, we don't have that. Okay? How is it that we got these perfectly round spheres when you look at them in a telescope? And then you just got this little piece of debris. And you say, oh yeah, the planets are made of little pieces of debris. It doesn't work that way. It's not going to work that way. The planets have to already be together to have gravity. So if they're not together, they don't have gravity. Now that's the naturalist solar system that we're talking about. But naturalism doesn't work. You can look at class 2. You can look at class 4 when we talked about the Big Bang Theory. It's not working. It's not going to work. The universe doesn't stand on its own. And so I'm going to go ahead and move past that and say now we have a created solar system. It doesn't have to be, and the thing is that there's a lock in the language there. Solar system, sun system. But as we start to look at the history of this, we'll start to see where things kind of open up a little bit. Now, so we have the planetoids, we talk a little bit about the planets. Basically, you should have these rocky planets all clumped up because they're closer. And then the outside is the gas planets. But hold on. What about Pluto? I said, well, Pluto's not a planet. Well, Pluto's got its own moons. I think it's like got 4 to 6 of them. I could be wrong, but they do have them. Okay? In fact, they have very weird orbits. And Pluto's got a weird orbit too. And it's definitely a solid planet. So what do you do with that? It's not going according to plan. And you got the other planets. You have Venus. Now, a lot of these other planets, they have these electromagnetic fields, and we have an electromagnetic field. Venus don't. Why? Shouldn't everything be natural? Venus is about the same orbit. Shouldn't say the exact same, but let's say it's within a close range to the Earth. The Earth has a big moon. Got a big old moon. Bigger than any of the other moons. Sorry. But anyway, they got the moon, and that helps the Earth have life. Why doesn't Venus have a moon? It's about the same size. And then they're all coming from the dust clumps, right? Wasn't it all one big donut dust clump? These things don't work out. Mercury seems to have a little bit too much metal from what I hear. Too much density. Then on the other hand, you got all sorts of weird anomalies. You got Jupiter spinning 10 times as fast as the Earth. There might be 6 times. Either which way, as you study the evolution of the solar system, you find it doesn't make any sense. Alright, so then we go down, we look at what's the history of the situation. Originally, you had this guy Ptolemy, and he did come up with a geocentric system. And you go to the Earth, and there's the moon, and you got the planets, and then you got the sun. Oh, there we go. There's the sun. Yay, pretty. Alright, and then basically he started to notice though that it wasn't perfect circles that were coming around the Earth. And so then he started thinking about these epicycles. And before you know it, it'll look like a doily. But basically, the papers that we looked at in the last class showed where it wasn't an issue of evidence that got people to leave Ptolemy. It was just that the mathematics was too wild, and so Copernicus started thinking about it, and he said, no. Nah, it's got to be the sun. And they switched over. Instead of the Earth being the center of the universe, the sun was the center of the universe. But that wasn't the last of the geocentric system. They had another guy named Tycho Brahe. And Tycho Brahe started to he actually synthesized these two positions. And we didn't have as much need for all of these epicycles, okay, all these loops and stuff. Instead, you had something more clean. Now, if you look here, we have the Earth in the center, but the sun is acting like an anchor. The sun is moving around this orbit, kind of like a racehorse, or as Psalm says, like a bridegroom running a circuit. But as the sun is running around, it is taking the rest of the planets with it. And then what are these right here? Well, these are the stars. And the stars are all in an orbit, and they're carrying the sun. And basically the Earth is not moving everything. No, the Earth is resting. See, the Earth just happens to be at the right place. It's not moving everything. Everything else is moving. Okay, and that's what we learned in class number 10. That everything, the whole universe is moving, and all these stars have so much mass and so much gravity, and they have electromagnetic energy. That's what we learned in class number 10. If I'm wrong, it's 11. It's called Handling my Light Work. But this was an obvious observation. And also, I'm not going to get into this too much today, but it wasn't just an even spin around the Earth. There was shifting for the seasons. And we see that in the ancient history when they dealt with Stonehenge. If you look at here, this is like not only an astronomical model, but this is also a model of Stonehenge at the same time. This is how they learned to tell time. And you see the sun rotating around, and basically it would go up and down like a barber pole. All right, and I know it's not to scale, but it would go up and down like a barber pole. All right, and that would provide for the seasons. So basically, we talked about a lot of this stuff. You have the issue of the ether that's moving things. You have the issue of the electromagnetic energy, and then you have the spinning universe all building up to now. And that is the physics which has proven this system. And the whole of the secular Western world has basically sided with heliocentrism. And so after Tycho Brahe, not only did he make that, he did all the observations after 35 years to help us to understand what the solar system was. But then he died. And so when he died, his assistant Robert Boyle, he goes in and he takes the notes and reinterprets them into heliocentrism. So geocentrism has to be possible because it was using the same solar system. It's the same geometry, okay? The Earth is the same distance from the sun. Everything's moving the same. It's just, what point are you standing in? What's your point of reference? But when we understand the nature of the ether, then all of a sudden we see how there is a substance, how the ether winds are moving everything, and how everything's interrelated as Mach was going on. Now, at that point, what was supposed to be the zero when we talk about heliocentrism and geocentrism, what was supposed to be the goose egg, turned out to be 50-yard line. Okay? Turned out to be 50%. So all of society has been under this conclusion that geocentricity is 100% wrong, heliocentrism is 100% right, when actually you're starting at 50%, understanding the ether drags it over into geocentrism. Now, this next set of evidence that I'm going to bring up, it's not something for the physicist. What we've dealt with has done the physics of it to prove geocentrism. But what they have on their side is the culture and the politics. They have developed this culture that has brought this up and put it into the subconsciousness of children who've grown up under that understanding. Christians let it happen, but honestly, it was because it wasn't affecting the fundamentals of the faith. There's nothing that is wrong, okay, done to the Bible because you think, well, even though things look heliocentric, they must be, even though things look geocentric, they must be heliocentric. So because they thought, hey, this is safe, they just let the whole issue go centuries ago. Not the 1500s. They had a big battle, especially the Catholics. But they have things that they call evidence that are actually anecdotal. And an anecdote is not something that proves it, but it's still something within the realm of science, as in a case study. Okay? These help you to practically know a truth. Okay? And that's why they're there in science, because they're good for your practical knowledge. Okay? This helps you to learn a principle in the terms of common sense. Okay? How do I know that the earth is spinning? They would offer two anecdotes. One, when you flush your toilet, or you pour water down a drain, or pour it in a bucket, or whatever, you'll always notice that the water spins. And then when you see it spin, it'll be, just remembering, and forgive me, but I think everybody knows this, okay? So if I got it wrong, you'll get it right. But it'll be like, I think clockwise. Is the water drain clockwise? Let's see here. Yeah, I'm going to say clockwise. And then when you go below the equator, you'll go counterclockwise. And so they would say, that proves it. Problem. What about the equator? In the equator, you would have to have the water flow straight down, because it would be evenly divided. But we don't have record of that. All we have record of is it either goes clockwise or counterclockwise. I think my research team is looking up over there just to check that. But then the other one is called Foucault's Pendulum. And you might see this if you go to a museum. It is a pendulum that hangs from a big chain, and it's swinging back and forth. And every hour, it starts to change the angle a little bit. And then what they'll do is they'll have some of these little plastic things, and, the pendulum will knock them over. And you can see it happening throughout the day. And they'll say, you see that turn is because of the spin of the earth. But even, I've got a quote from Einstein written in the science language, but I got a quote from Einstein that says, there's no optical thing that proves it. And that Foucault's pendulum could be explained just as easily by a spinning universe as it could be by a spinning earth. Okay? It's relative. So, I'm bringing up these anecdotal evidences on our side, on the geocentric side, not because that's going to prove it to a physicist, but it's going to help you in common sense terms to understand the reality of what is going on. So, the first one is the North Star. Hold on here. All right. You have the, all right, give me that. All right, here we go. If you all like time-lapse photography, it's always fun to go out at night and put one of these things on. I think they usually do it like a couple days, maybe a year. But what they'll notice is they have all the stars, and then what will happen is as they view it day in and day out, they start to see something. And so it all starts to come into play. And if you're in the northern hemisphere, you'll see the Polaris North Star right in the middle. And everything else is now moved and made a circle. If you are in the southern hemisphere, then what you'll see is a big donut. There will be a bottomless pit and everything there. That's also a scientific evidence for global Earth. But basically, you go up north, you see that again. And the North Star is directly north of the Earth. And it doesn't change. It doesn't change if it's on this side of the sun or if it's on that side of the sun. it's always directly north. And we'll usually just think that is the tilting of the axis. See that? There's the North Star. But yet there's also other things to this. But yet here we have this circle showing the universe moving. Now they'll say that's relative, blah, 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 anecdotal evidence. But that makes you think. Next anecdote is the butterfly. What happens is, and also I think that I'll start with the other one. Planes. When you go into an airliner, and let's say you're going from New York to LA. Now, there are things that affect this, okay, which is the wind and storms, weather. And then there's also the time zones. So you got to factor out the time zones, but you could probably just take a clock, okay? Take a clock with you. If the weather doesn't get bad, go from LA to New York, then go back from New York to LA, or other plane trips from east to west, and it goes at the same time. And you could ask the airplane pilots. They say, does it take much longer, naturally, this way to that way? And what they found is that it's about the same time. But if the Earth is spinning, then shouldn't one plane ride cover more distance faster because of the spin, and the other one going slower because of the spin? That's the natural assumption. And they found that the planes take the same time going east and going west. But also, I apply that to the monarch butterfly. The monarch butterfly starts from Canada and will fly down south all the way to Mexico. Little bug flying up in the altitude. Why is it? You know, we could say, oh, you got a big jet and blah, blah, blah. Why is it that the spinning Earth is not even affecting the flight of a little butterfly? Well, it's a big butterfly, but it's a little insect, you know. It's little to us, right? It's about that big. Okay? So, basically, there's another illustration to kind of get our minds to it. And then this one I've had fun with. All right, I know my art's not that great. Producer, your name okay?
Jeremy, fine.
Okay, Jeremy. What do you think? There's the little roots. What do you think that plant is?
It's a sunflower.
Woo! We got it. I'm an artist. All right, now that sunflower. You know what it does when it's nighttime? It all hangs low. The flower just bends over, keeps it down. And then, when the day comes out, the sun comes out, then that flower starts to aim for the sun. And wherever it is, it'll be reaching for the sun. Okay? Now, I bring this up because when we start talking about relativity and perspective, we tend to think in terms of, well, that's the way I think about it, and this is the way they think about it. When the sunflower has to move to face the sun moving, is the sunflower thinking that the sun is moving? Or is it reacting to the sun moving? In other words, this is a physical thing. Okay? It's not a perspective of the sunflower. It's just that the sunflower is made to where its organs are not affected by the Earth's spin, but they are affected by the movement of the sun. And these are things that you have to understand in the big picture. Not only is the Earth spinning, according to the secular cosmology, not only is the Earth spinning, but the Earth's going around the sun. But not only that, because that's what you're thinking. You're thinking that it's just spinning and then going around the sun. But actually, okay, what the common man misses is that Earth is spinning, going around the sun, going around the Milky Way. Now, if you are into young Earth creationism, you might be embarrassed by me bringing up the concepts of geocentricity. But I'm going to ask you something. It takes 225 million years to get around the Milky Way. The sun's working hard. It's going like 250 kilometers a second. And it's dragging everybody else with it. But my question for you is, if the universe is 6,000 years old, it's not even 1%, not even close to 1% of the distance to go to the Milky Way. So why does God have us moving around a Milky Way that we're never moving around? And how can we really know that we're moving around the Milky Way? Okay? That's an unknown naturalist assumption. But let's go and look at some of the stuff. Why would the Earth be unique to any other part of the solar system or the universe? The easy answer is that we're all from Earth. There is, they say, from the sun's perspective, nobody's on the sun. Okay? That thing is so hot, it's fusion with gases and plasma together. Okay? It's super hot. Nobody lives there. That's not a perspective. The Earth is where we live. And I know that some people would say, well, if you look at like even Neptune's moving past the speed of light argument, which I do explain in the last video, the thing is that that's part of a body. Okay? Now, if I throw a punch, all right, basically, if I throw that punch, where I do a stab with my fingers, okay? The thing is it my fingers that are traveling that fast, or are they part of the body that's moving? You see? Just like all these other things, that's the whole universe in one body moving, okay? But we go back to this and we think about, why is the Earth special? Now, the Earth has a specific distance from the sun. And in that realm, you can only have life because it has to be so hot and yet so not hot. But there's many other things that are involved. You have the moon. The moon is geocentric. Why do I say that? Because you only see the man on the moon, you never see the dark side of the moon. The moon is always facing the Earth, no matter where it's at. Okay? It's always facing the Earth. The moon is essential for the oceans to oxygenate. Those waves keep the environment together. The sun is essential at that point. And the Earth has this electromagnetic field which connects to the sun. Doesn't connect to Venus. Okay? But there is a electromagnetic portal connected to that Earth. And yet also, there are things every 2 years called a solar eclipse. I did that one wrong. There we go. Alright, I know I'm a bad artist. That's not the point. Alright, so basically, with the solar eclipse, the moon is at a distance that The sun is 400 times farther away, and it's got a shape 400 times wider that aligns itself with the moon so that you have these solar eclipses. Meanwhile, you got the North Star up here, don't you? Oh no, you got the North Star over here. Now, the sun is in a special alignment with the moon, and both are in a special alignment with the earth. Okay? And there, the earth is in this special alignment with the North Star. And the sun is supposed to be going at 250 kilometers a second and carrying everything, all this stuff is supposed to be going around the Milky Way without a hitch. Okay? It doesn't work. Another thing I think Robertson Jenis noticed was that there is a retrograde motion of Pluto. And at Pluto, what Pluto does is that as it's going around in its solar orbit, all of a sudden, it'll do a big circle. And guess what time it does that? When the Earth is in between the Sun and Pluto. So the Earth has a unique position. And if the Earth was too big, the gravity would push so hard that it would sink all the continents and the Earth would be covered with water and get poisoned. If the Earth was too small, then all the gas would float away. There is a perfect alignment that goes on with the Earth and shows that it is special. And once we understand it's special, then we don't have a problem with its special place. But if it's special, who made it special? The Lord our God. See y'all later.